Boman Kemp has been producing galvanized area wells for over 50 years. In the year 2000, we received our first report of a galvanized area well that was showing signs of corrosion. Over the next several years, we had multiple reports of premature window well corrosion. This problem was occurring primarily in the Colorado and Utah markets. We dug up a number of these area wells and replaced them with new area wells, and to our surprise, the replacement area wells also rusted out in a short amount of time. Over the next few years, we spent a substantial amount of time and money looking for the cause of the problem. Our analysis included studying all of the materials and processes involved in producing our galvanized area wells. We found that the materials and manufacturing processes we had used successfully for decades were not at fault. In the meantime, we continued to stand behind our product while looking for answers. In 2005, we hired the services of Qualcore Engineering, a consulting company specializing in detection, diagnosis, and prevention of corrosion. Qualcore's research found that the failed area wells experienced corrosion because a corrosion cell had been created. A corrosion cell occurred because a low-resistance path between the area well and the rebar was introduced through the anchoring hardware. 4 components are necessary for a corrosion cell to occur: an anode, a cathode, an electrolyte, and a metallic path connecting the anode to the cathode. When these 4 components are present and with the right soil conditions, rapid corrosion can occur. In our situation, the window well is the anode, the rebar is the cathode, and the soil is the electrolyte. A metallic path is created when the area well comes in contact with the rebar, either through rebar touching a metal buck or on wall mount area wells when an attachment bolt comes in contact with rebar during the installation process. If the attachment bolts or buck are touching the rebar, a metallic path is established. If there is no metallic path, the circuit is not completed and a corrosion cell will not form. Therefore, the best way to prevent a corrosion cell from forming is to ensure the buck and the attachment bolts do not come in contact with the rebar in the foundation. Since you can't see into the concrete, the only way to know definitively that a corrosion cell has not been formed is by testing. There are 2 developments in home construction that have increased the chances of corrosion cells forming. First, new structural engineering requirements, which have substantially increased the amount of rebar used in new home construction. More rebar means more chances of inadvertently connecting the area well to the rebar. Second, UFR ground. The introduction to the electrical code of the use of UFR ground, which grounds the electrical system to the rebar in the foundation. The UFR ground and network of rebar function as an electrical conductor. These changes in home building practices have an impact individually and together. Qualcore's research helped us to identify exactly what was causing the window wells to corrode. Their subsequent recommendations are based on standards set by the National Association of Corrosion Engineers. In summary, there are 2 things to do to help avoid the creation of a corrosion cell when installing an area well. Number 1, position rebar around a window in a way that the rebar won't make contact with the buck or the mounting bolts. With the considerable amount of rebar going into the foundation, this requires a little planning and inspection before the foundation is poured. If the buck or the attachment bolts end up touching the rebar, there is a high probability that a corrosion cell will be created. And number 2, conduct proper testing before and during the installation process to make certain that the buck, attachment bolts, and area well are not in contact with the rebar. The great value of testing is that you will know as you are doing the installation if you have errantly connected to the rebar, and you can easily fix the problem right then. The further you advance in the installation process without testing, the greater your risk and expense for fixing the problem. Testing protects your investment of time and materials. The 2 methods of area well installation are buck mount and wall mount. Since you will be doing testing with both methods, we will explain testing first, then walk you through the steps of buck mount and wall mount installations. The test you will be conducting is referred to as a continuity test. Continuity tests are used in electronics or electrical circuits to verify that current flows effectively through its intended path. For example, if we test this wire with a multimeter it shows that there is a continuous flow of current through the wire. However, if there is a break in the wire, the metallic path is separated and there is no continuity. In our situation, we will use a continuity test to make sure the area well is not connected to the grounding system, specifically the rebar and the foundation. Knowing that the area well is not connected will give you confidence that the installation was done properly. Tools you will need for continuity testing: digital voltmeter, also known as a multimeter, and a copper sulfate electrode. Steps for buck mount installation. 1. Take your first reading from the UFR ground. Locate the UFR ground. The UFR ground is typically 18 to 24 inches long and usually located around the garage. Set the voltmeter to 0.20 DC volts. Remove the electrode protective cap and press the pointed tip into the soil. Moist soil will give you the most accurate reading, so if the soil is dry, don't hesitate to add some water. Take a voltmeter reading from the UFR ground and write down the readings. This becomes part of the baseline for the rest of the testing. A typical UFR ground reading will be between -0.11 and -0.25. For the home shown in this video, the UFR ground read -0.18. This is normal. Test the window buck. Scratch through the finish with the red lead and take a reading of the buck. On this home, the continuity test on the buck read -0.61, a 0.43 volt spread. If you do not achieve a 0.20 or greater spread, it is an indication that a metallic bond was created and the buck is hot. Corrective measures would need to be taken, but since the buck read -0.61 and is not hot, buck mount installation can proceed. Mount the area well. Back out the top 2 bolts in the window buck and remove the rest of the bolts. If the grade requires the area well to be installed 12 inches or more above the buck, the top of the area well will need to be secured to the wall with additional concrete attachment bolts. Be sure to do a continuity test on each bolt used outside of the buck. Hang the area well on the top 2 bolts. Install the rest of the bolts with washers, then remove the top 2 bolts and install washers. The installation is complete when the area well is fully installed and the buck, attachment bolts, and area well have been tested and show that there is no connection or metallic path to the rebar. The galvanization on our area wells is sufficient to protect the area well for many years, provided that it's not part of a corrosion cell. We have observed in a few circumstances corrosion cells being created with other metal structures coming in contact with an area well. One recent example was the metal lathe used to secure mortar for a veneer stone installation. This should be avoided. Our products are designed to have a long, useful life. When installed properly and verified by testing, we warrant our area wells for 10 years.